All right, so we're going to focus on how we solve for an angle in this section. And if we know the value of a trig function and we want to find the angle theta, then we use the inverse trig functions. And we did that in the first semester. We did that a lot when we were solving right triangles. In most cases, with the right triangle, we know that we're looking for a first quadrant angle because those are the only kinds of angles that can be in a right triangle. But we're going to find that just in the general case, not restricting ourselves to a right triangle, there might be two possible answers for the value of theta if I know the value of a trig function. So what we're going to do to approach this, right, the calculator will only give us one angle, and oddly enough, sometimes it's not exactly the angle, one of the angles that we're looking for. So the way that we're going to approach this to make sure that we get the angles that we want is to first find the reference angle alpha. And alpha is a first quadrant angle that corresponds to the positive value of the trig function. So even if I know that, say, cosine is a negative 0.513, I'm just going to first pretend that cosine is the positive value and find that first quadrant angle. And then I can use the symmetry that we talked about in the last section to find the angles that I want, right? So if one of the angles that we want is in the first quadrant, then we get that angle. That angle is just the reference angle that we found. If what we're looking for is an angle in the second quadrant, then we get that angle by taking 180 degrees minus alpha. Again, that's just sort of realizing that the reference angle over here in the first quadrant, just kind of if we reflect it over here to the second quadrant, this angle here in the second quadrant is the same as 180 minus alpha. We're just kind of moving back by alpha degrees. Similarly, if I'm looking at the third quadrant, I'm going to take 180 degrees plus alpha. And if I'm looking for a fourth quadrant angle, I'll take 360 degrees minus alpha. Again, alpha is always, this reference angle is always measured from the x-axis, never from the y-axis. And I just sort of went through it as if we were measuring everything in degrees, but we are sometimes measuring our angle in radians. So the same principles apply, but instead of 180 degrees, we'd have pi radians. Instead of 360 degrees, that's 2 pi radians. You'll want to make sure that your calculator is in the right mode. In this first example, I know that I'm looking for an angle in degrees because they tell us where theta is between 0 and 360 degrees. So first, we'll note that sine theta is 0.6374. That's a positive. And where is sine positive? Well, sine being the y-coordinate means that it's positive in quadrants 1 and 2. So I'm going to make a note of that. So I want this angle, which is alpha, and I want this angle, which is 180 minus alpha. So first, sine alpha is positive 0.6374. I'm finding the reference angle. And if sine alpha is 0.6374, that means that alpha is arcsine of 0.6374. You may also use the notation where the superscript -1, like sine inverse like that. And that's fine to use. In fact, that's how they show it on your calculator. I'm a fan of the arcsine notation. I find it to be a little bit less confusing. So you'll see me use that notation more. So I'm going to find arcsine of 0.6374 on the calculator here. So I'm going to hit the second button and then sine 0.6374. And I get 39.6 degrees. Okay, so there's my reference angle. Now I'm going to find the angles that I want. So in quadrant 1, I know that theta is just equal to the reference angle, so 39.6 degrees. There's one of the angles I want. And in quadrant 2, I'm going to take 180 and subtract my reference angle. So 180 degrees minus 39.6. And that's 140.4 degrees, and make sure I put the appropriate units here. And those are my two angles. These are easy to check because I can just make sure that when I plug in my calculator's in degree mode, sine, not inverse sine this time, but just sine of 140.4, I will get something very close to 0.6374. We did have to round that angle, so I might be slightly off, but there it is, 0.6374, and then, you know, some more digits after. Okay, let's try another one. We're going to find theta, and this time they tell us that secant theta is negative 7.704. All right, so first of all, we don't have a secant button on the calculator. Secant is the reciprocal of cosine, not the inverse cosine. And so the first thing I'm going to do is just rewrite this. If secant theta is negative 7.704, that means that cosine theta is negative 1 over 7.704. And so I know the value of cosine. And the first thing, or the next thing I'll do is find the reference angle alpha. So if cosine theta is negative 1 over 7.704, then cosine of alpha, remember alpha is a first quadrant angle, so everything's positive in the first quadrant. This is just positive 1 over 7.704, and so alpha is going to be arc cosine of 1 over 7.704. And I can enter it in the calculator just like that. I'm going to make sure I close parentheses. So let's see, whoops. Arc cosine, or inverse cosine, 1 over 7.704, close those parentheses, and I get 82.54 degrees. Okay, so I know the reference angle. Now, what are the angles we're looking for? The first thing I need to realize is, okay, if cosine is negative, that means that the x-coordinate is negative, and I'm looking at quadrants 2 and 3. So my second quadrant angle, I'm going to take 180 minus alpha. My third quadrant angle, I'll need 180 plus alpha. I get 97.46 degrees for my second quadrant angle. And in the third quadrant, 180 degrees plus 82.54 degrees. $262.54 degrees. All right, let's try another one. Here they give us the value of cosine as a positive 0.870. And it says find theta, and again it's in degrees because it's from 0 to 360. This time they're telling us the value of cosine and they're giving us extra information. They're saying sine is also negative. So what this extra information gives us is it narrows it down. Normally, if cosine is positive, I'm looking at quadrants 1 or 4. But in quadrant 1, sine is positive, so that means that we're only looking at quadrant 4 here. So that's the angle we want, and we're going to find the reference angle and then subtract it from 360. So we know that cosine alpha is 0.870. So alpha is equal to arc cosine of 0.870 I get 29.54 degrees. Now to get the quadrant 4 angle that I want, I'm going to subtract that from 360. $330.46. All right, in this next example, I know that they, it's a similar kind of question. They're asking us to find theta, and they're telling us the value of a trig function. This time, however, I know that what I want is an angle that's in radians, and I can tell because here they put theta between 0 and 2 pi. So this is definitely radians that we're looking for. They tell us that cosecant theta is negative 1.133. So I know that sine theta is negative 1 over 1.133. And so sine alpha is a positive 1 over 1.133. Alpha is then arc sine of 1 over 1.133. I get 61.96. Now look at this. In degrees. I didn't switch the mode of my calculator. I knew that what I wanted in the beginning, right? We noticed I need radians. And I forgot to switch the mode of my calculator. That can lead, that's a common type of error that can happen to lead people to the wrong answer. But I was able to tell as soon as I got a result that there was no way that that was in radians. When you find an angle in radians, an entire revolution in radians, from angle 0 to 360, in radians that's just 0 to 2 pi. 2 pi is 6.28 something, right? So if I get numbers like 61, like something that's big, there's no possible way that that could be radian. So there's a little tip-off that I was in the wrong mode. I'm going to change my mode to radian mode and try again. Arc sine of 1 over 1.133. And I get 1.081. Now, radians are dimensionless, so when you write an angle in radians, you can leave the units off entirely. Some people like to write RAD, and that's fine. I think, sometimes adding more information is usually never a bad idea. So there it is. There's our reference angle in radians. We know that, let's see, we're looking for an angle where sine is negative. So the quadrants that we want, if sine is negative, it's got to be in quadrants 3 and 4. Because sine is the y-coordinate. So in quadrant 3, I'm going to take pi radians and add alpha radians, and for quadrant 4, I'm going to take 2 pi radians and subtract alpha radians. So pi plus 1.081 is 4.223. And in quadrant 4, we're going to take 2 pi and subtract 1.081 radians, and we get 5.202. All right, let's try one more. We're going to find theta now if tangent is negative 1.380. Again, we're looking for radians because it's from 0 to 2 pi. And I'm going to start just by saying, okay, well, tan alpha is a positive 1.830. I'm going to find that first quadrant reference angle. And tangent is negative. Remember that tangent is sine divided by cosine. So if tangent is negative, that means sine and cosine have to be different signs, right? One has to be positive and one has to be negative. And that happens in quadrant 2 and quadrant 4. So when after I find that reference angle alpha, I'm going to subtract it from pi to get the second quadrant angle, and then I'll subtract it from 2 pi to get the fourth quadrant angle. So tan alpha is a positive 1.830. That means alpha is arctan of 1.830. We get 1.071. And now we can go ahead and find the angles that we're looking for. So one of our angles is in quadrant 2. I'm going to take pi and subtract 1.071 radians. I get 2.071. And in quadrant 4, we'll take 2 pi minus 1.071. Okay, 5.212.